Okay, ma'am. Good day to one and all present here. I feel privileged to extend my warm welcome to you all gathered here for the 5 days International Online Faculty Development Program series on Advanced Techniques in Computing Sciences and Applications organized by the Department of Computer Science and Applications, Savita College of Liberal Arts and Sciences CMETS in association with IKAC Human Resource Development Center and institutions in Chicago. CMATS was established in 2005. We are very proud to share you all that our CMATS has been re-accredited by NAC as A++ grade with the score 3.6. CMATS ranked with many more ranks. To mention a few, Savita College of Liberal Arts and Science ranked with the Indian Institutional Ranking Framework has conferred with national rank 19, state rank 7 in the University Ranking India in 2022.
Ma'am, is it audible?
To Arts and Science stream. CMATS ranked A++ grade by
No, ma'am. For me, it's not audible.
Ranking for Outcome-Based Education Ranking 2022. Savita College of Liberal Arts and Sciences to emerge as preeminent college by imparting excellence in education of global studies, research, culture, and creating individuals with ethical values to serve the society. On behalf of Savita College of Liberal Arts and Science, I extend our profound gratitude towards our respected Chancellor of
But your voice is not audible to me. Okay, just a minute.
Collector Madam, shall I proceed? On behalf of Savita College of Liberal Arts and Science, I extend our profound gratitude towards our respected Chancellor of CMATS, Dr. N.M. Virayan Sir, Director Academics, Dr. Deepak Sir, Director Dr. Ramya Deepak Madam, and Vice Chancellor Dr. Chandam Shivaji Sir. We wish to express our heartfelt gratitude to our Principal Madam, Dr. Gunita Aram Chandok, who gives direction to every student and staff members. She has been our guiding light and always encouraging us to give our best. We have offered the programs BSc Computer Science, Computer Applications, BSc Artificial Intelligence, and BSc Data Science. We have well trained the known CBCS system, which provides an opportunity for the students to choose courses from the core, elective, and skill-based courses, and foreign language courses too.
Audible, ma'am. Collectively, ma'am, your voice is not audible to me. Okay.
Yes, ma'am. The students are offered.
Now, is it audible, ma'am?
Yes, sir.
The students are offered study abroad programs with.
I'm not able to hear your voice, ma'am.
Sir, we are able to hear her voice, sir.
Sylvie, madam, shall I proceed? The students are offered study abroad programs with Asia Pacific University, Malaysia, and completed the international workshop and credit course on artificial intelligence and data analytics. It will be prolonged with various courses offered from US and UK universities also. Students trained by hands-on coding, implementation of research projects, and comprehensive training for every subjects they have studied. Once again, I welcome our chief guest and all the participants to this session. Now I call upon Dr. K. Kalaiselvi to introduce the chief guest. Over to Kalaiselvi, madam. Kalaiselvi, ma'am, please introduce the guest.
Yeah, yeah, yeah. Thank you, ma'am. Yeah. So, just a minute, I will share my screen. Is my screen visible, ma'am? Okay, just a minute. Yes, ma'am. Is it visible now? Yeah. So, good evening to all. So, sorry for the inconvenience caused from my side due to that some problem in my mic. So, so thanks for the intro about me. So, so today's topic is cloud-centric IoT. Um, so, organization of my presentation. These are all the things I'm going to cover in this particular session. So, evolution of cloud computing and IoT, and overview of cloud and IoT. Then IoT market share in India in the year 2020, because last 2 years I have not taken for the due to the corona. And IoT components, what are the things in the IoT we are using, basics of IoT protocol, and the main motto of this particular session is how we can create a cloud-centric IoT. So that architecture part, and what are all the IoT cloud platforms that are available in the market as of now, and how we can integrate the IoT with the cloud by using AWS. we have more services in the AWS. So which services we are using for this particular session? Maybe this particular one: IoT analytics, IoT site-wise, IoT events, and IoT core work. And how the real-time video streaming or real-time applications I want to process in a real time, which tool can be used. So here the one tool called Apache Spark, we have a number of tools. So this particular one will give the more enormous way to do this particular task. So that we will discuss more about this Apache Spark. So first one, I will start with the cloud, then I will start with IoT, then we'll go for the cloud-centric IoT. As from the 70s and 80s, we have the mainframe computers and supercomputers that occupy the market. So during that, the initial stages of virtualization that start, but in the evolution of cloud only, we have started with the cloud. That is virtualization, full virtualization. And in the 90s, we have the distributed computing, because before cloud, we have the distributed computing, grid computing. Then we came up with the cloud computing. Then nowadays we are using fog, edge, and so many other computing things. But still, we are using cloud as one of the storage medium. Not only for storage, we are doing compute, network, and storage. These are all the main things. In that, we came up with everything as a service now, because every service, whatever you are getting from the internet as a service. And the next one, in 2006, they launched this cloud services, the basic things like SaaS, PaaS, and IaaS, that is software as a service, platform as a service, and infrastructure as a service. So these three will occupy the market as of now, because all this particular one, SaaS, PaaS, IaaS, in all the cloud providers like AWS, in Google Cloud Platform, the IBM. So whoever may be the cloud providers, they will concentrate on this particular one. So how we can create those services? Maybe in our lab we used OpenStack, because for the cloud deployments and integration with other aerospace applications, it is very easy for the OpenStack. Even in your lab environment also, you can create your own server using OpenStack. Maybe in the end, I will give you the overview of how our lab cloud is developed, because I have created this cloud infrastructure here, and we have more number of compute nodes, network nodes, and the storage. So these things I have created here, and we are using currently 8 compute nodes here. And the first, in the cloud services, we have the basic services like 16 services that are provided by the AWS, like EC2, S3, and most network services and IAM. So these are all the basic services they have given. After that, now we have in the cloud, we have enormous services, even everything as a service. So whatever the application you are creating, that you can provide it as a service. And in the 2008, they came up with analytics also. So instead of getting a data, and we are processing analytics in a different way, but through this AWS analytics, we can analyze the data, we can get the real outputs in that particular way itself. No need to go for other servers or analytics engines. We don't need that particular one. So as of now, 2022, we are using this, all the analytics, all the data processing, all the IoT sensors data, everything we are processing inside this AWS or the Google Cloud Platform or Microsoft Azure. So these three things are providing this particular services. So, okay, which services will be best? Because in a year by year, it will be changing. So as of now, Azure is having the more number of customers compared to the AWS. 2 years before, AWS have the more market, like 16 billion. So, but Azure takes over, and we have more number of customers in the Azure. So next, evolution, how it can be evoluted from this traditional distributed computing to the cloud. So this particular one, we are doing all the manual operations like client server applications. Then now we have the semi-automated during this virtualized data center. We call it as VDC. So during this particular one, number of servers are clubbed together to form a virtualized data center. Like Google will have their own data center in Hyderabad. So a number of servers are clubbed together like a cluster, and everything they use it as a server. So it means that they have more number of virtual machines that are created in that particular data center. So what is this automated? This particular one, yeah, this automated means we no need to manage that particular services, whatever the applications we have deployed in cloud. The cloud service provider will manage everything. It's a fully automated one. So what is this elastic, reliable, and this particular one? So it means that maybe you have aware of the Flipkart sales for the 3 days, like big billion sales, or the Amazon, the big billion days. So everything they are using only for 3 days. So whether they adopt more storage or more number of computational power they need at that particular time, or whether they go for more number of servers. So they use only cloud. We call it as spot instances. So during that particular time, for example, if we take 10 lakh customers are using Flipkart per day. So during that particular 3 days, maybe a crores of people will join to that particular offer period. So how the Flipkart is managing everything? So they will use only spot instances. Whoever is joined to that or whoever is hitting that Flipkart site, they will create more number of spot instances. Instantly for the 3 days only, they will use that particular storage. Uh, AWS will have the scalable environment like scale in and scale out. For example, I can move it from 1 TB to 100 petabytes. So like that particular options that are provided from the service providers like AWS or Microsoft or other things. Maybe we'll have one question. Okay, can we create that particular infrastructure? If you have the hardware, you can create that particular one because everything it depends on the infrastructure only. So that's why all the major GMs only they are providing this infrastructure. If small companies are developing this particular one means they are not able to provide all the services like YAS and PaaS or SaaS. So that is the difference why we go for only Azure or IBM or Oracle clouds. Even the top one will be Azure, Amazon, and Google Cloud only because they are providing more number of services. So these are all the essential characteristics, how we can access the cloud and what are all the services it provides and what are all the deployment models. So first one, a broad network access, anywhere you can access and you can increase and you can also decrease the scalability. And measured services means I can measure how much I have used for this particular service, how much I have to pay. On demand self services means suppose I'm going to use this particular one for an hour only. Then that particular time I can subscribe and I can remove that particular subscription. Resource pooling means we have a number of services that are available in the cloud. So I want to club all the resources. I want to take it as a pool manager. Then I can use this resource pooling. So whatever the resource I need, I can use the shared one. I can use this particular one. Like the service-based companies like CTS, Infosys, they will use the shared medium only because we have two types of storage that can be occupied in the cloud. That is shared medium, like shared storage and dedicated storage. So dedicated storage means that is costly. So compared to the shared one, so like Infosys, CTS, they are sharing the resources that are common. That is public. We will call it as a public one. So even the user can see that particular one, maybe a CTS or the Infosys employees. But dedicated one means only who is owning that particular one they can access. So the to avoid this private data, we can store it in the dedicated one, and all the public data we can store it in the shared storage. So we can reduce the cost for that particular services. and three basic services: infrastructure, platform, and software. And what are all the deployment models? So, like Gmail and other things, it's like a public one. So, it's a public deployment model. Private, for example, for our company, we need one particular private cloud means I can create that particular one. You can ask the AWS also, they will provide on a chargeable basis, they will create compute nodes, how much we need, how many network nodes we need, and what are all the storage S3 they need. So based on your requirements, they will create this and they will provide as a service. So hybrid, I can provide both the one. So like educational institutions, they can deploy it as one community. So hybrid, we can create this public, private, and community under one wing. So we can use whichever one we want. Based on that one, we can create this hybrid infrastructure models. So coming to the next topic called Internet of Things. So basic things, how we can connect with things by using the internet. So we can connect machines, tools, or whatever the devices we have as of now, we can connect by using this IoT. So as of now, we have over 40 million things that are connected to the internet, and things connected to the internet are projected to cross 20 million in the future, because all the companies, they are looking for Internet of Things devices only. Maybe for your information, I'm sharing this particular one. Whatever the one we are talking, maybe 5 years before or 10 years before we learned this Internet of Things. But evolution, it takes now only. In the agricultural or healthcare sectors, we are using this IoT. But in the foreign countries, they are focusing on TOT, like things of things. Like from the smart refrigerator or whatever the things we are using, we are controlling through the internet. You are in somewhere, but you are controlling your devices through the internet. But here they works on TOT, that is things of things. For example, I will give example for this things of things. Take 10 by 10 room, okay, 10 cross 10 room. So inside that you have 10 lights and also the four fans that are working. When you enter to the room, in the door side, you have one particular light that will be automatically switched on, and you are moving to the end of that particular room. That is last end of that particular room means automatically the first light that will be sending that communication information to the last light, and it will automatically switch on, and the first light, it is automatically switched off. Same thing for the fan also. So when you enter, all the environmental data and sensors, it will collect the data and it will pass that information to the last one. So this is how the project that are now doing from our universities. So one particular lab, DMS, we are doing this things of things devices. How we can uh, connect with devices and how the devices will communicate with other devices. So this particular research is going on, but in India, we are focusing only on IoT based devices, IoT based connections. But here, the next level evolution that came from that IoT devices. And what is this unification of technologies in the IoT? So we can use it for low power embedded system, and we can integrate this IoT with cloud. Maybe we'll see this cloud centric IoT platforms. And by this particular data, we can use big data concepts like 4 Bs of big data. So how we can process that particular data, how we can get the exact output of that particular real-time data. And we can use all the machine learning models or deep learning models to convert this particular IoT data to a maybe a particular accurate data we can get it from this particular one. So everything is a combination of this particular one when we go for this final output of like cloud centric IoT. Because from the devices you are collecting all the data, you are processing all the data in the cloud. In the cloud, we are processing the data by using machine learning or the Hadoop or how to map reduce that particular data. Everything it will be processed in the cloud. No need to store it in the static databases, and we can process that particular data again. We need to store that in the cloud. That is not needed. So how that evolution that started in the cloud? So we have pre-internet, so like human to human communications. So through this, we came up with the internet of content like World Wide Web. So from this, we come up with internet of services. First, the web 1.0, then 2.0, then next one, internet of people, like how we can connect with the people through social medias. Like before Facebook and other thing, we have Orkut and any other social medias that occupies. Then now we came up with Facebook, YouTube, Twitter, and other things. So how we can communicate with machines? So this particular one we can have it in the machine to machine. So next level evolution is things of things. IoT it is moved to the TOT. So this one maybe we discussed a lot about this. What is IoT? This one is a market share. So how the IoT that is used in a market. So which sectors will occupy more in this particular one? So maybe this we can have healthcare. We have 10%, and in the retail we have 9%. This particular one, like IoT data, we are using in this particular market, and agricultural it's slowly up. So now it is increasing after this COVID-19 situations that are over. Then in the automotive industry, so major companies like automations and robotics, so that particular companies they focus on this IoT based applications. And all the other utilities, so it will come up with applications. They use this 25%. So this it will increase maybe in the future if this IoT it is moved from TOT, because all the companies are looking to this next level evolutions only. So this one is the architecture of how the Internet of Things evolved on how many devices as of now we connected, like 40 to 50 million we connected, and we have many sensors as we are now using, like ambient light and accelerometer, then barometer, temperature sensor, proximity sensor. So everything, this particular one, every devices, whatever the devices now or in the future, it will come. This particular sensors, even in your smartphones, you have this particular one. So have when you are moving to some other particular places, everything is watchable. Then next one, how the market it will move. Okay, so as of now, the GDP for this 2020 14.4 trillion for the European Union, not for the India alone, for the European Union and the all global leaders. Then next one, industries, whatever the industries, the IoT they are using. So majorly it is focusing on this particular one, like automotive industries. So they are focusing on this particular one because in the vehicles, like Internet of Vehicles that come, so there we are using this IoT devices, and maybe the Tesla and the other things, how they are working means from this one vehicle to other vehicle, how we can communicate, how we can pass this information, how we can control the other vehicles during this parking or any other during the vehicle riding and everything. So in banking sectors, we are using this IoT devices like Samsung Card Pay and other things. Everything it is based on this. And marine, like ship informations, where it is located, how we can pass this particular information. Then property like real estates. So how we can link with data that are from the government websites, and energy, okay, and aerospace. Here in our lab, we are focusing on all the sensors, whatever the things we discussed, everything we are connecting. We are collecting all the data from the aircraft. So currently we are doing a project called urban air mobility. So maybe I will explain you this particular one at the end. So because it's a current research trend topic, because nowhere it is developed in this particular concept. Maybe it will come up with digital twin concept. Maybe at the end, we'll speak more about this UAM, urban air mobility. And healthcare sectors, we used this IoT market share and also the IoT devices. Maybe I have one example for this. We'll discuss more about this healthcare sector. So how the devices that are connected, how the communication that happens in the IoT and also to the cloud. So here, these are all the things that are connected. Okay, then it will be connected to the local network. So this local network, we can have a number of LAN, MAN, WAN, or wired or wireless, whatever the things we are using for connectivity. You can use this particular one, and it will be connected to the internet using this internet gateway, and it will be connected to the backend services. Here, the backend services, it may be a cloud storage, or you are using inside the cloud storage, you are doing all the analytics, this particular one. And for communications, we are using this particular one. So from the devices, we collect all the data and we will process here in this particular cloud storage. So the cloud service providers provide infrastructure and the how we can process this, how we can connect this, everything it will be provided in the cloud service provider. We call it as CSP. So who are maybe like AWS or Google or IBM. So this particular infrastructure is common when you deal with IoT and you want to store it in the cloud. So how we can interact, how we can communicate this particular one. Maybe you can see this example diagram. So this radio and processor and all the sensor informations that are connected to this, and this is your internet gateway, what I have shown in the last one. So this proxy server will be connected to this internet. This is not compulsory one. If you want, you can use this proxy server. Suppose you want to connect from different services, and this will connect to the web socket, whatever the client and server communications you are establishing, like HTTP or other things. You want secure connection means you can use SSL and TLS, transport layer security, and the secure socket layer. This one, it provides more security. If you need, I need maybe blockchain related security also means, then you can adapt that particular one in the cloud server. So you have to integrate with blockchain in this particular cloud server. So this cloud server, it will be provided by the cloud service providers. So there, by using this, maybe AWS IoT analytics or AWS or Azure analytics through this particular one, or Azure Synaptic analytics. So that particular service, it's provided for analyzing all the data. Like you can do all the data analytics inside the cloud platform itself. No need to take the data and run it in the outside the environment. That is not needed in the cloud. And what is this actuation? Based on the reply from this particular one, it will send it to analytics and it will process all the information, and we can send it that particular data to the devices. So this way, an IoT implementation that will be happening around the world. So based on your application, whichever the device you are going to connect, this particular architecture is common for every devices you are connecting. So these are all the service-oriented architecture. As we have already discussed this particular one, this sensing layer, the bottommost sensing layer, it will detect all the data from the devices, like sensing all the data from that particular devices. It will be send it across the network. Maybe you are using LAN or mobile network, or your software defined network. That also we can use it here, but you need to create which network you are connecting, what is the orchestrator. So everything you need to map it here. Then only you can connect with software defined networks. Then here, all the service layer, what it will store means, it will connect with all the networks. Here, whatever the things we have presented, this. So whichever layer you are using, this will be connected to this service. So this services, we are storing in the service repository. So what is this repository means? Uh, for example, if you take MS Office will have PowerPoint, Excel, Word, and other things. So we want to store it as a one particular package like MS Office means we need to create this repository. Same here in this particular data, we need to store all the device data into your repository so that whenever you are not connected to the internet, you can get the data from the service repository. That is, we call it as a local repository. Suppose if it is in the cloud data we want to store it means, then this repository will be connected to the internet as a storage, cloud storage, and we can get all the relevant data in this particular service repository. Then this particular one is an application front end or whichever the APIs you are connecting and whichever the interface you are using, you can connect by using this interface layer. So this from the device you got all the sensor data and you are connecting with the network and the service integration. All this service repository process, everything will happen here and it will be sent it to the application. So we have built-in applications also. If you want to use this, then you can create an API, or we have other uh, uh, example. We can take it as container. So now in the software market, we are not focusing more on the API. So we are focusing on the Docker containers. So what is Docker means? We can create a microservice architecture as a one particular container. Whenever we need, we can deploy that container as a service. So the Docker, Google provides this particular application called Docker engine. Through that, we can create enormous number of containers into the specific applications. Then that particular container, we can use it whenever that particular application is needed. So I can use that container as a service. I can use it for a month. Then I don't want to use that particular container means I can deactivate that particular container, use other containers, whatever I need. So this is how the containers that are famous now. So all your protocol stacks like Flutter and other things. So whatever the developments environments we are using now containers only. So even from our lab, we are doing one project how we can integrate with UAM through the containers. So because it is easy, the cost wise also it will be reduced whenever we deploy containers into the cloud, because we can reduce the size of that particular one size of the container and I can store it in the cloud so that the cloud storage cost that will be reduced. Next, how the IoT and the associated technologies are related. So here we have big data, cloud, smart grid, and Internet of Vehicles, then machine-to-machine communications, then telemedicine, then cyber physical system. So then all the communications like 3G, 4G, and 5G, and software-defined networks. So I can use this IoT in all these particular applications, and I can send the data, and I can process the particular data, and I can get the result in the cloud also. So this particular IoT along with cloud, so we call it as cloud-centric IoT. So instead of having this everything as a separate applications, we are integrating this particular one with cloud-centric IoT. So these are all the stacks like IoT stack versus web stack. So the major part of this particular one is this particular one. Like what are all the protocols that will be used to create an IoT application and how we can send it. So this particular one, MQTT and COAP, constrained application protocol, this particular one will be used for sending that particular data information to the applications. So maybe we'll see what is this MQTT and COAP. So it is like a public subscriber model. This one is a lightweight messaging protocol. This it's introduced by the IBM in the 1999, and why they created this particular application means we'll see from these examples. So maybe this particular one. maybe take this particular example as temperature sensor. Okay, so it sends all the information to this broker. So what is this MQTT broker means? It will act as a message broker. So message broker means it will collect all the informations from different devices. So and it will send that particular information to that whichever the sensor it collects the data, because it has more number of messages. So where I want to send it, which device I want to subscribe, which device I want to send it as this 30 degrees Celsius, or this one will be 30 degrees Celsius. This particular information I want to send it to different devices means I can use this MQTT as a one messaging protocol. So this for this we are using this message broker. So it will do the publish and subscribe messaging pattern. So what is this particular pattern means? It uses topic. Maybe I will give one example for this. Maybe you can take your house. So inside your house you have a living room and other rooms. So like kitchen. So what is the temperature of your kitchen? That will be sent as a one particular topic to the message broker, and the living room temperature that also be sent to the message broker. So based on that particular one, it will be sent as a one particular house temperature. So we can divide it into individual messages and we can send it to the particular device. So here the topic to which a client is subscribed is updated in the form of messages. This is very important because each individual topic only it will give the information to the message broker. So how it can be designed, like remote connections, unlimited bandwidth, and small code footprint. Like we can use it for remote connectivity. Suppose I need to connect my devices from the remote. Maybe in the office I want to connect means I can use this topic or message broker informations. So these are all the three things: publishers, subscribers, and brokers. So here we are using lightweight sensors for publishing that particular one, and all the sensor data it will be subscribed and it will be sent it to the specific application. So we can use this message broker to connect and classify the sensor data. So this is the one example, like connect, disconnect, subscribe, unsubscribe, publish. So connect means whenever the device is connected, all the information that will be sent it to this MQTT broker and it will be sent it to the laptop. So I need to subscribe this particular one to publish that particular information. So this protocol uses this publish subscribe model. It's a event driven. What is this event driven means? Whenever a new event is occurred, it will send that particular information. If it is not triggered, then it won't send any information. Whenever the temperature changes or that particular information changes, it will enable the topic to that MQTT broker, and the broker will send that information to the other one. So what is topic means? It will use it for the routing information, like how the router will works. It will send all the routing information to the router or to the hub. Same here, the topic will be used as a router and it will be sent it to the MQTT broker, that is message broker. The next one, each client they want to receive messages means they need to subscribe this particular topic and it will match with that particular topic means it will be sent it to the same device. If it is not, it will send it to the other devices. And we can use it for scalable solutions like healthcare and the other automation industries. We can use this MQTT brokers like Facebook and other things. They are using this MQTT data only for chat and other things. They will use this particular information. So what is this MQTT topic means? It's like a simple string. We need to create a hierarchy levels by using this slash. For example, house, living room, temperature. So I want to send the topic for the living room temperature. Then I can create this house as a major one in that living room and that particular temperature. I can subscribe this particular model and I can send that information to the temperature information of living room to the house, or which device I want to send, I can send it easily. So here I can use wildcards called plus and also the hash. For a single one, I can use only for the living room I want to send means I can use this syntax as house living room / temperature. That is topic information. This I can send it to that particular one. For example, if I want to send it for kitchen, house / kitchen / temperature. This is for single level. Suppose I want to use it for multi-level. For example, house, kitchen, living room, kitchen, and other things. I want to send it as a one particular topic. I can use this particular one. House. Sorry. This particular house and hash. This can be used inside this particular one. So, like single wildcard or the multiple wildcards, multi-level wildcards, we can create inside this MQTT. And where the MQTT that can be used for the Facebook Messenger, whatever we are now using in the Facebook, it uses for the MQTT only. So, message queuing telemetry devices, this particular one. And AWS, it uses with Amazon IoT. Maybe in the further slides, we will discuss more about this Amazon IoT, how the AWS IoT is connected, how it can communicate. And Microsoft Azure IoT also uses this MQTT protocol only. And everything IoT platform, it is also one of the IoT platform. It uses this MQTT. And for Adafruit, it is a free MQTT cloud service. It provides all the experiments related to the IoT. So these are all the different applications we are using MQTTs. The next one, constrained application protocol. How we can use this in a machine-to-machine applications. Okay. This particular one, it can be used in the constrained nodes and the networks. So here, for example, web transfer protocol, we can use it for constrained means for only this particular node, it can be used with some constraints like rules, whatever we are specifying. Only this fog node will be enabled during this particular time. So like that, we can create a particular node. During that particular time, I can use this COAP. So this is designed for machine-to-machine applications for building a smart energy and building automations. Like one machine want to communicate with other machine by using a device called IoT. In between, you are having that particular device. So I need to provide a constraint by using the protocol, because in the protocol we will specify the rules. So I can use this constrained application protocol, and I can specify that particular which protocol design I am using, that I can specify. And this particular one, how it works means it based on the request response model. So like in the networks, you have seen like TCP, UDP. So TCP, it uses this first one, you are sending a request, then it will send the response. Then the data that can be sent along with this particular one. We call it as piggybacking. Like we don't want to send the request and the response as a separate one and data as separate one. We will send response along with data. So it will reduce the waiting time. It can be avoided. Maybe one example is a sliding window protocol. So that particular one we can take, and we need to wait only during that particular time, and it will move it to the next slide, and you can take the data. So same here in the constrained application protocol also, it uses this request response model. This. So how it can be used means maybe you have aware of the OSI model. So it uses the session layer protocol. So what is session layer means? During that particular session, it is active, then it will send all the information to the presentation. That is next level layers. Then it will send all the HTTP and REST information to the next level stage. So how it can process means this particular one. Maybe I can take this example like client and server. So we are having a connection and you are getting an acknowledgement. Once the connection is established with the server, you are getting an acknowledgement. So this one is a conformable message. Here non-message means you are not sending any request or reply. You are just and you are not establishing any connections. Like TCP, we have three-way handshaking. So first we will request the particular server, and we can have a hi and hello messages. Then we will send a handshake message, and again the data that will be sent. So here we are doing this by using this connections like piggybacking messages. So first we are sending connections. From the acknowledgement itself, we are getting acknowledgements plus data. So this is the one advantage if you use this piggyback message. Separate message means what will happen once the connection, you are sending a connection request, then acknowledgements. You have to wait when the data that can be sent, then you can send the acknowledgements. So here, this particular waiting time that can be reduced if you use this particular piggyback messages. So why the TCP IP protocol stack is very familiar means because of this particular model. So even now we are using this TCP IP protocol stack because of this particular reason. Next, how the general architecture of cloud-centric IoT. So this is the main part we are discussing now. So how this cloud-centric IoT is developed, okay, how it goes. So here the device tier, these are all the devices, n number of devices that are connected, and this particular one will be connected through the gateway. This gateway can be any access point, and here all your message broker or all your applications like public subscribe model that will be developed here, and it will be running in the cloud like AWS or Azure. This application tier, so all your SaaS applications that will be running here. So this can be established by using these platforms. Maybe I will skip this particular one. I will go for this particular one. What is this cloud centric? What is this device centric? This is very, very important when you design a cloud centric or device centric. What is this cloud centric means? All your devices that are connected to the data center, and you will do all the analytics and decision making in a real time. So not in a static, everything is a real time. We can do this particular one here in the real time application itself. So that is the important one here. Device centric means, for example, I can take one example for this. Device centric, you are connecting all your devices in the cloud, so you need internet connection. Whether your internet connection works in all places, maybe a question mark. So some places, maybe in the deep forest, your internet connection is not working. So how I can send that particular data to that particular cloud? So what it will do means, here we can have the edge devices or the fog devices that can be connected to that particular deep forest. It will collect all the data. Whenever it moves to the cloud or internet-based environments, it will send that particular data to the cloud. So that is the device centric. So during that particular maybe a kilometer or that particular time, that particular data will be stored in a edge device and it will be moved to the cloud. So this is how the cloud centric and device centric that works. So as of now, we are focusing everything on the cloud centric applications only. So cloud centric means I can get the IoT data, I can process everything in the cloud. So no need to go for this particular one. So maybe I'll move to this. What are all the cloud platforms we have, like AWS? Okay. So these three things, like basic services that are provided by the AWS, this particular one, compared to this traditional one, as we are using this EBS, S3, and EC2, these are all the basic services. Maybe if you log into the aws.amazon.com, you will know these services, basic services. So these basic services I have clubbed into a one particular page. So major things, suppose you want to do any certifications related to the AWS, basic cloud practitioner, that's enough. You can learn all the 16 basic services. So this is your IoT core, how I can connect things and with the AWS. This is your AWS region. Okay. We have 27 regions all around the globe from the AWS, and maybe Chennai will have one particular one, and Mumbai is the region for India actually for this AWS. And Google will also have the regions, number of regions. So this particular DynamoDB, Lambda, everything that connects to this IoT, okay, devices, and we can process all the device informations to this real-time dashboard. So in the dashboard, I can get connected and I can do this processes. So this, maybe I will skip these informations. I will go for diagrams. Maybe I will share this particular slides. Maybe you can refer it, because everything, it is not present in the internet or any other, because everything we have worked in this particular AWS services have taken from this particular information. This is an IoT analytics, how the cloud and IoT that are connected, how I can do the analytics. Okay, this is how the collect, process, and store will do all the analysis, maybe structured or unstructured, because Facebook data or Instagram data, Twitter, everything is unstructured one. I can process this and I can build this particular infrastructure. So maybe I will skip these things. I'll go for these Spark alone. Yeah. So this is your IoT, how it is used in healthcare. Okay. So this patient information, all your wearable devices that are connected to this health rate monitor sensor. Okay. Everything it will be processed in the IoT cloud, like AWS or the GCP. So this particular one, all your data will be processed by using this analytics processing engine. How this analytics processing engine works means it uses Spark. So Spark, it uses in-memory processing. For example, if you take online weather forecasting data or online stock market data, so everything it works on Apache Spark. So like NSE or your BSE data, how the stock market data every 5 minutes or every seconds that are changing. How it can be updated in a real time, they will use only Spark. So Spark, it will run with your in-memory processing. What is in-memory means? For example, my system is 64 GB RAM. So I can run n number of maybe 10 different virtual machines inside my machine. So it takes all your data directly run in RAM, that particular 64 GB of RAM, whatever I'm telling. So this I can run it. Same if I run it in the cloud, we have 8 nodes from our lab. We have server. So that particular server, I can run it in the real time. So no static databases. We are not downloading the data and create it as a database, and running means that is a static. But real time means all your data, it is not stored anywhere in the cloud or anywhere. I can process the data, I can get whatever the results I need. So that is the advantage of using this Apache Spark. So before that, we have Apache Storm and Flume. So that particular one will give uh, the real time processing, like video streaming applications I can do, but it is not in memory. In RAM, it is not processed. So why we need more RAM for our machines means because of this particular reason. So this one, maybe you can refer this particular slides related to the Apache Spark. So here I have given enough information for Spark. So how it works, what is RDD, okay, how it can run it inside the RDD. So this is the basic one. So maybe you can refer this particular information. Yeah. Yes, ma'am. That's all from my side. Yeah. So I can connect with n number of devices and use this Spark or the machine learning applications by using Spark. Maybe any questions from your side? Maybe
Thank
I
you,
can
sir.
check the messages.
Thank you, sir. Dear participants, now you can clarify your queries with the resource person.
Maybe I have not covered about this AWS IoT analytics fully. Maybe because of time, have reduced this particular one. I will share this particular slides. Maybe you can refer it. If you have any doubts or anything, maybe you can mail your questions to me.
Hello, sir. Can you hear me?
Yes, sir. It's audible.
Yeah, I am Dr. Nandagopal. I need one clarifications from, just give me one example how this IoT things has been working on. You have given more example, but I want some live example in AI oriented.
Live example for which
Yeah,
application?
artificial intelligence.
Okay, okay. Maybe one project, whatever we have done it from the previous institute,
Current
whatever I
projects
worked.
you are handling. That's
Current projects. Yes, sir. I will explain you this. One is maybe one agricultural project we have done. So in that particular one, we placed 4 sensors. For the example alone, I'm telling this particular one because in our project we used this. So sensors from the agricultural soil land So we collected all the data of that particular farm, and
Okay.
we moved that particular data to the real-time environments, like getting the soil data from that particular field, and we have processed that what is the soil level that will be used for the farmer. For example, the farmer is going to cultivate potato, for example. So for that potato, after he installed all the sensors and he cultivated everything, but during that time, if he got loss, means then that is not the predictive analytics. Before that, we need to give what is the estimate and what is the uh, profit he will get. So for that, we designed one particular app. So in that particular one, what we have done means we collected all the information from the soil land, and from that particular soil land, for example, during that we have split it into 4 quarters, like fall, spring, and winter, and that particular one. So that 3 months, if the farmer is trying to cultivate this particular potato, what is the best season, and how much sensor he can fix it inside that particular one, and what is the profit he will earn during that particular time. So we gave all the predictive analytics. So before he invests money in that particular land, he will do. We have done all the analysis and we have given to this particular farmer. So there we used only AI models, because for all the analytics we used AI models. We collected random data from different uh, farmlands. Maybe we collected the soil data from the Chengalpattu district. So in that particular district, we got from the agricultural office. So we got the physical data, that is manual one, and we changed it to the Excel file, and we moved the real-time data file to the cloud as a machine learning model. Then we used number of algorithms for that particular data. Then we predicted this particular one. We created one app. So we are giving that particular app to the particular Chengalpattu region.
Okay.
So
Thank
this
you.
is the real-time example. Whatever we have done it for the IoT works. So as of now, we are working on the in my lab of work. I'm working on the UAM, that is urban air mobility. So what is this particular one means? Maybe if you are aware of digital twin. So digital twin means whatever the device that are working in a real time. First, we will create a simulation model. We will check for the accuracy of that particular model, whether in the real environment also is it working same or different. So first we will check in the simulated environment. Maybe the accuracy of simulated environments, it is not actual with the physical one. So we are going to create a simulated model. So already we have done 95% of that simulated model. So we are checking from the cloud aspect. We created one particular OpenStack cloud. So we are going to test it for multiple vehicles. Now we have implemented only for one vehicle, one urban air mobility vehicle. So there we are running maybe one aircraft with different PX4 and AirStream applications. So from that, we are using this particular application. So this is the real-time work we are doing now in our lab.
The same way, is it possible to do any projects in weather forecasting, the particular place, the particular district?
Yeah, weather forecasting, already a number of research works that are already done related to this. Maybe how exactly we can predict that particular weather, maybe in the deep forest or the particular environment, maybe in the NASA data and also the ISRO data that are available in their site also. We collected all the data. We are working on other project related to the weather forecasting.
Okay.
So
Thank you, sir.
maybe mine too. Yeah, thank you, sir.
Thank you. Thank you very much.
Thank you, sir. Yeah, any other questions? Maybe beyond it, maybe I have one question from the participants, Kokila. Beyond the theory, where the student has to start getting to the IoT. Maybe if you want to do some IoT related project, get some sensors from the market. It's like a 150 rupees or 200 rupees only. You can get it. You can use Arduino or Raspberry Pi kit. So through that you can develop a simple application. Then from that you can learn. So what are the sensors we can purchase, and next level how we can go for a smart devices how we can create. So basic one, you need to experiment that particular one, because theory you can easily learn from the YouTube and other things. But if you want to test it, you can go for this particular one, because in all the uh, maybe if you take Chennai, Ritchie Street and everything, all the sensors that are available. Maybe if you spend 5,000 rupees, you can get all the sensors. Then you can do all the things. Even one Raspberry kit, you can do a number of projects.
Sir, good evening, sir.
Yeah, good evening, sir.
Sir, can you tell me which which URL is the best for do the IoT project from online, sir?
Online, because we are not referring to one particular URL. Maybe I will share that particular links. Maybe to Kalesh ma'am. Maybe you can get that one, because I'm not referring to one particular things. Normally, we will refer only journal papers. Okay, so how they implemented this particular one. Basics. Maybe I will share some books related to the IoT. So that books, it may be useful for you to learn basics of IoT. So because if you see the videos in YouTube, so many things are there. So maybe you may get confused with that particular one. So if you are good in basics, refer some books or some survey papers of IoT. Maybe a taxonomy of IoT. So so many papers are available in the Google Scholar. You have a number of papers. Even in IEEE also you have a number of papers. If you can refer that one, it will give you the recent trends and also the basics of IoT. Yes,
Okay, sir. Thank you, sir. And then one more question is what now, sir? How the student can easily to learn the IoT, sir? Sir, if I'm taking a Raspberry Pi now, so the student want to write some code. So how can to learn for that code, sir, for easy manner?
Yeah, if you use Arduino, you can connect with your laptop, and it's like a 2 to 3 lines of code only. It's not like a C program or C++ program, because in a 2 lines of code you can connect to that particular device and you can send that information. So if you use Arduino, you can easily connect to that particular one. Even if you type it in YouTube, how to connect Arduino with your laptop, this particular simple basic scripts that are available. So you can take that particular one, you can do the programming. So basic one is an Arduino only. You can learn that particular one, you can do the projects. And in future, you can connect with Python. So because in Python, so many libraries are available. So you can connect to that particular one with that particular Arduino. Then you can do all the parallel processing, because if you connect with devices with laptop, normally we will go for the parallel programming only. So for advanced applications, maybe you can go for OpenMP and CUDA. So CUDA, it's like a research level, they will do this programming. So basic level, you can go for Arduino. That's enough. If you want to do for research related project, then you can go for OpenMP and CUDA. CUDA, CUDA.
Sir, and then one more question, sir. Last question, sir. Sir, whether it is possible to work with the Firebase of cloud? It is easy manner,
Yeah,
sir.
Firebase and all, maybe it may be a basic one. What I'm suggesting, if you are working for projects, then you can go for MongoDB, because so that you can connect with NoSQL data, like unstructured data, you can connect. Firebase and all, you will have a basic one. But if you go for MongoDB, then it will be easy to connect with that particular unstructured data also. Because nowadays, whatever the projects you are working, everything is unstructured. We are not working in a structured one like SQL or the Oracle data. Everything now, if you take the real time data, it will be a cluttered data, unstructured data only. So that one you can do it by using MongoDB or Cassandra. Cassandra is another database, so NoSQL database. You can use that particular one. You can learn that basics of MongoDB, then you can use that.
Sir, and then one more thing is what now if I go for the AWS now, I want to pay for the some amount license. So, sir, which cloud is useful for to use in open source, sir?
Yeah, open source, you can go for OpenStack, OpenNebula. So OpenStack, it provides all the documentation, everything. It is available freely in the online. Just you can have, suppose you want to experiment that particular one. OpenStack provides one APK, one OS, VDI file. So you can download it and you can experiment the dashboard. You can create a VM inside that particular one, then you can run your applications, a basic one. And because in our research lab also we are not using any AWS or GCP, we are using only OpenStack. It is a freeware, and you can connect n number of virtual machines inside that OpenStack. So basic one, to connect this particular one, you need a basics of Linux, maybe Fedora or Ubuntu, whatever the things you know. From that you can connect all your terminals, all your virtual machines to that OpenStack. The basic one will be Linux.
Sir, there is any tool, sir, to connect the Windows, sir. Sir, actually, when I take for the Arduino board and then Raspberry Pi, it will be connected only for the Linux. So, whether it is possible to connect the Windows, sir, or if we want to use any, we want to install any tool, sir.
For Windows, maybe if you want to create maybe Sigwin, that is a one tool that can be used if you want to run it in Windows, or Windows subsystem for Linux. Maybe you can try that particular one. We call it as WSL. Maybe you can try that particular one. So you can connect in the Windows also by using that PowerShell. We have the PowerShell in Windows. You can use that particular one and you can connect your Arduino. So that is the one basic thing you can use it. So WSL, Windows Subsystem for Linux.
Thank you, sir. Thank you so much for valid things. Thank you so much, sir.
Thank you, sir. Thank you.
Participants, we have posted the feedback link in the chat box. You are requested to give your valuable feedback. Now, moving to vote of thanks. Good day to one and all present here. First and foremost, I thank the Almighty for His grace showered upon us, and be thankful. Yes, we must thankful to everyone all the time. I take this opportunity to thank each and every one of you. Gratitude makes sense of your past, brings peace for today, and creates a vision for tomorrow. Let us be grateful to people who make us happy. They are the charming gardeners who make our souls blossom. I convey my warmest thanks to Dr. B. Sakthivel, postdoctoral researcher, Konkuk University, Republic of Korea, for the wonderful and informative session. Gratitude opens the door to the power, the wisdom, the creativity of the universe. My sincere gratitude to our beloved director, Dr. Ramya Deepak Madam. My heartfelt thanks to our respected principal for her guidance and support. My special thanks to Dr. Kalai Silbi, Associate Professor, for introducing the guest of honor. My heartfelt thanks to my colleagues and all the participants present here today. Once again, I thank everyone for making this program a grand success. Thank you. Thank you all.
Yeah, thank you, ma'am. Thank you for providing the opportunity. So, thanks to Dr. Kalashelvi, ma'am, and the college, Savita College of Liberal Arts and Sciences, Chennai. So, thanks for the opportunity. So, hope I have satisfied everyone. If you have any questions or anything, maybe ping me to my mail or my number. So, maybe I'll help you out for the projects or any other thing.
Thank you so much.
Yeah, thank you, ma'am. Yeah, thank you.